All right. Next topic I want to talk about is what's called order statistics. So order statistics are what we get when we take a collection of random variables and then we put them in order. Okay. So let's just define that first, is that let's suppose we have three or four independent, identically distributed uniform 0, 1 random variables. So of course, any given realization, they could fall anywhere, but let's say U1 falls there, U2 falls there, 3. Okay, then we write a parentheses around them, their index, to indicate that we're now putting them in order from lowest, smallest to biggest. Okay. So in this example here, this would be U1, this would be the first order statistic, second order statistic, third order statistic, fourth order statistic. Right. So the indices are in parentheses. They're not the same indices, they're the same variables. Then what can we say about the behavior of these statistics? So, in other words, given that we have 4 IID uniforms, what's the probability that the first order statistic is less than or equal to U? We know that the probability that any given of the statistic of the random variables is less than or equal to U is U by the distribution function of the uniform distribution. But the minimum of this class is different, right? In general, the minimum will be smaller, right? So the minimum is the first order statistic. What's the probability that the minimum is less than or equal to U? Well, what has to happen for the minimum to be less than or equal to U? Well, it means that at least one of them has to be less than or equal to U. At least one of them. And if we were to do it this way, if we were to think about it in terms of at least one, that's a union of events. And we could do it by inclusion exclusion, but it would be pretty cumbersome to do that, potentially. So instead, what do? Well, the minimum being less than or equal to U is the complement of the minimum being bigger than U. Okay, now why do we like that? Well, the reason why we like that, so the probability of the complement is 1 minus probability of the event. So it's the complement of the minimum being bigger than U. And what does it mean for the minimum to be bigger than U? It means that all of the U's have to be bigger than U. All of them. And so it doesn't have to do, we're not working with the order statistics anymore. So this is now the probability of an intersection of I equals 1 to 4 of the event that UI is bigger than U. What's that? Well, the probability that UI is bigger than U is 1 minus the probability that UI is less than U for any given U, which is 1 minus U, right? So this is equal to 1 minus. Each of these probabilities is 1 minus U. There's 4 of them and they're independent. So it's 1 minus U to the 4th. So this is the distribution of the first order statistic. The density of the first order statistic. So as long as this is continuously differentiable, which it is, it's the derivative of the distribution function. we can easily take this, it's 4 times 1 minus u cubed for values of u between 0 and 1. And 0 otherwise. The expectation is the integral of the density of u times its density. By symmetry, we can actually do a quick change of variables. Instead of having this as 1 minus u cubed, we can change. So we can change a random variable by defining y equal to 1 minus u. That means that u is equal to 1 minus y and du is equal to minus dy. But this is the integral now. So we would have a minus dy, but y would go from 1 minus u, so it would go from 1 to 0. Okay, but that integral from 1 to 0 is the negative of the integral from 0 to 1. And so that's why we don't, and so that's why this is, it's equal to this. We break it up and we can see that this is equal to integral of 4y cubed minus 4y to the 4th dy, which is 1 minus 4/5, 1/5. So the expected value of the minimum is 1/5, but another way that we could calculate this is just by integrating the survival probabilities like we saw in the previous lecture. The survival probabilities are 1 minus, it's 1 minus this. So the ones cancel out, the minus cancels out, we get integral 1 minus u to the 4th du. This is easy to integrate, it's 1/5. Okay. So anyway, that's an application of these ideas in the uniform case to where we have IID random variables, and we talk about the order statistics, which is something that comes up in certain applications within statistics.